So another application that's really critical for quantum networks is for beam splitters is in doing Bell state measurements. So what are Bell states exactly? So Bell states are the 4 maximally entangled quantum states for a pair of qubits. And what this means is you have 2 qubits, and for their quantum state, whenever you would measure the quantum state of one qubit, the results of and then measure the quantum state of the other qubit, the results will be as highly correlated as possible. And there's 4 of these states that are all different, but they're all very entangled, and they're important for quantum networks for entanglement distribution and quantum teleportation. So how can we do Bell state measurements with beam splitters? So one implementation we can think about involves using a beam splitter and 2 photon number resolving detectors on the outputs of the beam splitter. So in this implementation, we have an entangled Bell pair entering into this beam splitter, and we can actually predict, again, from our unitary operators that we solved for previously, what's going to happen to this entangled Bell pair as it enters into the beam splitter. And I'll just be showing the results here, but if you have this psi plus state entering, you would get a single click on one of the detectors. If you have the psi minus state entering, you will get a single click on the other detector. And if you have the phi plus state entering, you'll get either 2 clicks at either detector or no clicks at all. And again, for the phi minus state, you will also get 2 clicks at either detector or no clicks at all. So we can kind of see what this tells us. This tells us that that we can definitely distinguish between the psi plus and psi minus, but we can't actually distinguish between phi plus and phi minus. So we can't, just by using a beam splitter and these photon number resolving detectors, we can't tell if we had a phi plus state or a phi minus state. And in general, for Bell state measurements that use beam splitters or that use linear optical components, you can't really do better than 50% success rate for the Bell state measurement. And this is kind of referring to the fact that we can't tell between the measurement outcome of two of these Bell states.